Electric vehicles, EVs, have revolutionized the automobile industry by being environmentally friendly and fuel efficient. Tesla, General Motors, and others still face EV battery fires. Even though these events are infrequent, they raise safety, battery technology, and public image issues. This video will discuss electric vehicle fires, lithium-ion battery safety, and manufacturer safety procedures. Be aware of electric vehicle fire myths as the electrification revolution continues. Comprehending the fires caused by lithium-ion batteries. To what extent does thermal runaway play a role in the ignition of lithium-ion batteries? And what is its definition? Lithium-ion batteries power current electric vehicles with their high energy density and efficiency. Thermal runaway is a phenomenon that may occur with certain materials, despite the fact that they have many benefits. An overheated cell inside the battery may cause this to happen, which then sets off a chain reaction that has the potential to cause the whole battery pack to catch fire. Thermal runaway may be caused by a number of factors, including manufacturing faults, physical damage, excessive charging, and exposure to temperatures that are beyond the normal range. The National Transportation Safety Board, NTSB, has brought attention to the fact that fires in electric vehicles, EVs, present dangers such as the possibility of electric shock to first responders and the possibility of the battery being reignited. Tesla-related incidents. What are the ways that manufacturing faults and physical damage contribute? A number of high-profile fire accidents have occurred at Tesla, which is a notable electric vehicle manufacturer. Flames erupted in several instances following severe collisions that caused damage to the battery packs. In Austin, for example, a Tesla car caught fire because it slid over the base of a traffic pole, which caused the battery to get damaged. Events of this kind further underscore the susceptibility of lithium-ion batteries to physical damage. In addition, there have been instances of Tesla cars catching fire without any incidents that occurred before them, which has raised worries about the possibility of manufacturing faults or software problems. Incidents affecting General Motors Corporation. What can other electric vehicle manufacturers learn from the way that General Motors has handled this issue? There were substantial issues that General Motors GM faced with electric vehicle fires, notably those that included the Chevrolet Bolt. These incidents exposed the risks associated with lithium-ion batteries. An investigation conducted by General Motors in April 2021 revealed that a rare manufacturing defect in certain battery modules was the root cause of the fires that were detected in Bolt cars. GM's battery supplier, LG Chem, manufactured the battery cells that caused the issue. One of the specific problems was that the anode tab had been damaged, and another was that the separator within the battery cells had been folded. These faults raised the risk of short-circuiting, leading to overheating and the potential for fires. The ramifications were significant, which prompted General Motors to initiate a series of recalls that affected more than 140,000 Bolt EVs throughout the continent. As a means of addressing the problem, General Motors temporarily paused manufacturing of the Bolt and collaborated closely with LG Chem to devise and execute a remedy. In an effort to reassure consumers, the business promised to replace any battery modules that were found to be faulty and extended the warranty on the car. Additionally, in order to lessen the likelihood of a fire occurring, General Motors encouraged owners of Bolts to restrict charging, prevent emptying the battery below 70 miles of range, and store their cars outdoors. It is possible for other electric vehicle manufacturers to gain useful insights from General Motors' approach, which includes the following: placing an emphasis on openness, working closely with suppliers to determine the underlying reasons, issuing proactive recalls, and taking swift action to rebuild customer confidence while simultaneously enhancing safety measures. A comparison of fires involving the internal combustion engine ICE in electric vehicles. When compared to other types of fires, electric vehicle fires garner greater attention from the media. When comparing electric cars, EVs, to conventional automobiles powered by internal combustion engines, ICE, it is vital to contextualize the fire dangers associated with EVs. There were an average of 287,000 car fires recorded yearly in the United States during the years 2003 and 2007, according to the statistics. This indicates that vehicle fires are rather prevalent. Despite the fact that electric car fires seem to get a lot of attention from the media, Studies indicate that they are far less often than fires that occur in gasoline-powered vehicles. Difficulties in putting out electric vehicle fires. What are the most significant obstacles that firefighters must overcome in order to put out fires caused by lithium-ion batteries? An important issue with electric vehicle fires is flame severity and difficulty extinguishing. Flames that are caused by lithium-ion batteries may reach temperatures that are substantially greater than those caused by gasoline flames, occasionally reaching conditions that are up to 1,000 degrees Fahrenheit higher. Because injured cells have leftover energy, these flames may rekindle hours or days after being extinguished. We refer to this phenomenon as stranded energy. This exposes emergency personnel to increased dangers and makes firefighting activities more difficult. Implications for the environment and human health. Could you explain the potential risks associated with using runoff water to extinguish electric vehicle fires? In addition to the immediate risk of fires, the combustion of lithium-ion batteries results in the emission of a complex combination of more than 100 different compounds. These pollutants include heavy metals, carbon monoxide, and hydrogen cyanide. These pollutants expose both the firemen and the nearby communities to environmental dangers and health concerns. A rising number of concerns are being raised over the toxicity of the smoke and the possibility of pollution from runoff water that is utilized in firefighting operations. Recent developments in safety and regulatory measures. Which new firefighting techniques are currently under development to manage incidents involving electric vehicle fires? To tackle these challenges, regulators are implementing various measures to enhance the safety of electric vehicles. The actions taken by regulator. For the purpose of enhancing the safety of batteries, governments are implementing rules. By way of illustration, South Korea has instituted a certification procedure for electric vehicle batteries, as well as regulations to avoid overcharging. Furthermore, to enhance transparency and safety, South Korea has mandated automobile manufacturers to disclose the companies supplying their batteries. Recent developments in technology. Recent developments in battery technology have the goal of lowering the danger of fire. Among the developments that have taken place are the use of batteries that are less prone to fire, such as lithium iron phosphate LFP, and the pursuit of solid-state batteries, which are seen as safer alternatives. In conclusion, although the widespread use of electric vehicles has revolutionized the transportation industry, it also leads to a new set of issues, particularly in relation to lithium-ion battery fires. EV battery fires continue to affect Tesla, General Motors, and other companies. Cases involving well-known companies like General Motors and Tesla demonstrate how difficult it is to manage these risks. This video will cover lithium-ion battery safety, electric car fires, and manufacturer safety protocols. However, General Motors has recalled Chevrolet Bolt vehicles, highlighting the impact of even infrequent mistakes in battery manufacturing. According to the research, fires in electric cars are significantly less common than those in vehicles with internal combustion engines (ICE), even though they have garnered a lot of media attention. However, electric car flames are hotter, burn longer, and are more difficult to extinguish, posing additional risks to the environment and emergency responders. The problem is made more difficult by the poisonous fumes and dangerous runoff produced when lithium-ion batteries are burned. If you enjoyed this video, don't forget to like, share, and subscribe for more.